let's go ahead and continue on Module 6, Lesson 4. We were on Example 6, or getting ready to start it. So these next two exercises kind of give you an idea of whether you understand the definitions listed above, like what it means when they say f of -1. So remember when I was explaining earlier, I said whatever's in parentheses is your x. So instead of saying f of -1, what your head should be saying, if you understand function notation, is when x is -1, what's y? So I look at my table. When x is -1, y is 8. And that's called finding the function value. So they give you the x. X is always what's in parentheses. You write down the y. F of 2 means when x is 2, what's y? So when x is 2, y is -2, or the function value is -2. When x is 8, notice there's no 8. That means there is no, or we just write none. Don't write 0, because 0 is the function value for 0. So you cannot write 0, you just write none. There's not an 8 listed. That means there's no y value for that 8. Okay, the next one is very similar. Again, this is tests you on your vocabulary. Find the range. Do you remember range are the y values? If the domain is, and domain, remember from our last lesson when we defined it, domain are the x values. So this is what my head thinks when I read this problem. I go, oh, they're giving me these 4 x values, -2, 0, 1, and 3, and they're asking me what are the y values that go with it. So using our methods from example 4 and 5 above, we're going to do the same thing. This says make x -2. So I go up to my original problem, and everywhere I see an x, I see 2 of them, I'm going to put -2. So f of -2 is -2, and we're inputting a negative. Remember how I said when you input a negative, you must put it in parentheses? So take the x out, plug -2 in, and then add 4. 4 plus 4, the answer's 8. So the output or the answer is always going to be your y value. Scoot this over a little bit so we're not off the page. So then we just go down the list and do the same thing. F of 0, so everywhere I see an x, now I'm putting in 0, is -2 times 0, so I don't need parentheses now because I'm not inputting a negative, plus 4. This is 0, 0 plus 4 is 4. F of 1, -2 times 1. Again, I'm not inputting a negative, so I don't need parentheses. It's not wrong to put them in. You just don't need them. -2 plus 4 is 4 minus 2, which is 2. And then last, f of 3 is -2 times 3 plus 4. So -6, positive 4 would be -2. But then we have to go back and look at what it says. It says find the range. So if you look on your last lesson, the definition of range is the set of y values. So my answer must be given as a set, just like my domain was given as a set. So we use the set symbols, and then we list our elements of our range, 8, 4, 2, and -2. And like I said on the last lesson, it doesn't matter the order. Usually we just keep them in the same order as the problem. So those are kind of good problems just to see if you understand the notation, the definitions, and so on. So let's go ahead and learn about the vertical line test on the next page. Okay, the vertical line test is used for graphs. So up until now, we've been given a set of ordered pairs and we looked to see if x was repeated to determine whether it was a function. That was from the last lesson, lesson 3. So if an x was repeated and assigned 2 different y values, then we said it wasn't a function. Well, we need a test for graphs too. So what if something's graph and I ask you if it's a function? Well, that's where the vertical line test comes in. And the vertical line test says if any vertical line passes through a graph in more than one point, the graph is not a function. So let me show you with this ellipse down here. So I'm going to pass a vertical line through the graph, and the graph is whatever picture is drawn on there. If it intersects in more than one point, 1, 2, then it's not a function. If it only intersects at once, then it is a function. But this one intersected the graph. We don't count the axis. We just look at the graph. It intersected that ellipse or oval or whatever you want to call it in 2 spots. So it's not a function. That means this x value is assigned 2 different y's, and this x value is assigned 2 different y's, and this x value is assigned 2 different y's. So it follows the same definition. No x can have more than one y value assigned to it. And the vertical line test shows us that. So let's go back to this line. If I pass a vertical line through this graph, and this is considered the graph, does it intersect it in more than one point? Nope, it only intersects it in one point, so this is a function. Now let's look at this horizontal parabola. Vertical line passed through this, intersects it in 2 different points, so this also is not a function. And there's a second part to this. If it is a function, identify the domain and range. We'll come back and do that. Let's just practice on the vertical line test right now. So when we pass a vertical line through this parabola, this is a vertical parabola. This was called a horizontal parabola. See, they're the same shape, but vertical, open, up or down, horizontal, left or right. Since this line only intersects it in one point, this is a function. Same thing with this V. This is called an absolute value graph. You'll learn about this in Math 120 and Math 150 if you're going the STEM route. So this again only intersects the V in one point. And it says any vertical line up there, but any vertical line I draw will only intersect at once. So this is a function as well. And same with this line segment. This is also a function. Notice the endpoints on this line segment. They stand for the same thing they did back when we were doing inequalities. A solid dot means that point is actually a point on the graph. An open dot means the line segment comes right up to there, but this is not actually a point on the graph. So open circle means it's not a point on the graph. Closed circle means it is, just like when we were doing inequalities. Okay, now let's go back and look at the domain and range. We probably won't get through all of them on this video, but we'll pick up wherever we left off. So anything that is a function, they want us to identify the domain and range. And I will tell you, this is probably one of the hardest things you learn in this class. So you really have to practice on Alex on this to get good. Or, cover up the answers and go back and try and do them on your own later. We're going to have a lot of practice in this packet with them, but this is definitely something that takes practice. So domain, as we learned on lesson 3, are the x values. And the x-axis is left to right. So when we're reading the domain, we list the leftmost x value first and the rightmost x value second. So I like to write that right above it just to remind me. And the reason order matters is because we're going to be using interval notation like we did with inequalities. Remember the parentheses and the brackets. And whenever you use interval notation, the smallest value has to be listed first and the largest second. That's why we always start on the left, because on the x-axis, the left side are the smaller values, the right side are the larger. So what I notice is this graph goes left forever. That means every single x value will have a point on the graph as we go down. And it also, because of the arrow, goes right forever. So every single x value is going to have a corresponding y because of that arrow. So if I asked you to write the domain in words, you would say all real numbers. But they want domain in written, and this will be for the rest of your math classes. Domain and range written in interval notation. So we learned back in Module 5, that means all real numbers is negative infinity to positive infinity. It goes to negative infinity, and it goes right forever to positive infinity. The range is the y-axis, and the lower values on the y-axis are on the bottom. The higher values are on the top. So when we do range, we go bottom to top. And I always write that just to remind myself. Sometimes I just go L to R, B to T, but I always have to start with the smallest. So what's the smallest y? Well, this graph goes down forever. So the smallest y value is again going to be negative infinity. And then we go to the top. Well, this line keeps going up forever. So because of the arrows, the range is going to be positive infinity. And I think you should make a little note right here. Every single line you ever draw will have the same domain and range except vertical and horizontal. So anytime I ask you for domain and range on a line that has 2 arrows, that's what you write. So every line except horizontal and vertical will have the same domain and range. So every single line, except for the special cases, horizontal and vertical, will have that. So you never even have to think. You see arrows on both ends, that means it goes left forever, right forever, down forever, up forever. These two are not functions, and this only wanted us to identify the domain and range on functions. So we do not have to do it for these two. On the next video, we'll pick up and do the domain and range here. I'll leave this here so you can see it. We'll do the domain and range for the 3 in the second row.